Open a website, drop in a photo, and it tells you what is in the picture. Nothing was uploaded. No server ran the model, and no API bill was charged to anyone. Google just made that the default. They put a real on-device AI runtime directly inside JavaScript, and it runs the exact same model files that already ship inside Android and iOS apps. The project is called LiteRTjs, and it landed on July 9th. It is the browser version of LiteRT, the on-device engine that used to be called TensorFlow Lite. Here's the part that actually matters. You do not convert your model into some web-only format. The same model file a phone runs is the exact file the browser tab runs, unchanged. And getting it running is genuinely simple. You install one package, point it at the runtime, and load a model file with the graphics card turned on. 3 lines, and inference runs on the user's own hardware. So how does JavaScript run a neural network at real speed? It mostly does not. LiteRTjs talks straight down to the hardware through 3 different backends. The floor is the CPU. It runs Google's optimized math library compiled to WebAssembly. It works in every modern browser, with or without a good graphics card. Does it actually pay off? Google's own benchmarks say up to 3 times faster than other web runtimes on the same models. And moving work from the CPU to the graphics card is 5 to 60 times faster on heavy real-time jobs. Marketing says no server and no API bill. We wanted the real trade-off. So, we measured 4 things ourselves: download size, latency, cost, and privacy. First, how big are these models really? We pulled 4 real ones from Google's public library. An image classifier is about 19 megabytes. A small embedder is only 4. Every cloud AI call pays a toll before the model even runs. The round trip out to the server. We timed it live, and the floor was about 240 milliseconds on every single call. Privacy is the same story, sharper. Run 2 million classifications, the cloud way, and you ship 700 gigabytes of user images off the device. On device, 0 bytes leave. Then the money, and this is where it flips. Cloud cost grows with every single inference. The browser pays once to download the model to each user, and after that inference is free. So where is the crossover? With that 19 megabyte model on an ordinary CDN, the browser is already cheaper after just over 1 inference per user. On a zero egress host, it wins from the very first one. Put real traffic through it. 100,000 users, 20 classifications each. The cloud bill is $3,000. The browser is $167, or 0. So it is cheaper, private, and low latency. Where is the catch? Because there is always a catch, and it is not the one the headline implies. The cost moved to the very first visit. Every new user has to download that model before anything works. And on a slow phone connection, 19 megabytes is a real weight, and not every model even fits. Input shapes have to be fixed, tensors have to be plain integer or float, and a big model can blow past the browser's memory limit. And you cannot split a model half on the graphics card and half on the CPU, and the fast path is not guaranteed. The graphics card route is uneven across browsers, and the neural chip route is still experimental, behind a flag. The WebAssembly floor always works. The ceiling depends on the device. So here is the honest call. Reach for the browser when the data is private, the volume is high, or it has to work offline. A small model, running on your user's own machines. Stay in the cloud when the model is huge, when the shapes are dynamic, or when you simply cannot count on the device. The biggest models still live on a server, and that is fine. The real shift here is quieter than 60 times faster. A whole class of AI just got a second home on the user's device. Reachable from plain JavaScript. Do not take our word for it. This is straight from Google's announcement, with the backends, the benchmarks, and the limits laid out. That is Film 8. The runtime, the model files, and our whole cost experiment are linked in the description. Build, ship, and scale. Now, without the API bill.